Welcome back to Easy ESS. This video, energy flows and nutrient cycling. How energy fuels ecosystems and how nutrients cycle endlessly through them. Master this, and you've got the foundation for all of ecology. Here's the central distinction you need. Energy and matter behave completely differently. Energy flows one way. It enters as sunlight, gets captured by photosynthesis, passes up through trophic levels, and at every step is lost as heat, never recycled. It's a one-way street to space. Matter cycles. Carbon and nitrogen atoms move between organisms, atmosphere, soil, and water. The same atoms are reused forever. Every carbon atom in your body has been cycling through the biosphere for billions of years. This distinction, energy flows, matter cycles, is the foundation. Every exam question builds on it. Two processes run the show. Photosynthesis captures solar energy and locks it into glucose. Only producers do this. Respiration releases energy for life, and all organisms respire 24/7, including plants. Exam mistake. Students think only animals respire. Wrong. Plants respire constantly and lose energy as heat, just like we do. The equation, GPP minus respiration equals NPP. GPP is total energy fixed by photosynthesis. But plants don't use all that for growth. Much goes to respiration and is lost as heat. What's left is NPP, net primary productivity, energy available for consumers. For exam data questions, if biomass loss increases, NPP decreases over time. Energy moves up the food chain, but only about 10% transfers between each level. Why? Organisms use energy for movement, growth, and maintenance. The rest is lost as heat. So if producers have 10,000 kilojoules per square meter per year, primary consumers get roughly 1,000. Secondary consumers get 100. Tertiary consumers get 10. By the fourth level, less than 0.01% remains. This is the 10% rule. Memorize it. It explains everything about food chain length. Food chains rarely exceed 4 trophic levels. Not enough energy left to support more. This means far fewer top predators than herbivores. Polar bears need huge ranges. Deer don't. What examiners ask? What happens when a top predator is removed? Trophic cascade. Remove wolves from Yellowstone and deer explode, overgraze vegetation, and change stream ecosystems. Energy loss explains why top predators are rare. Carbon cycles between 4 stores: atmosphere, biosphere, hydrosphere, and lithosphere. Photosynthesis pulls CO2 from the air into living things. Respiration and decomposition return it. Fossil fuels in the lithosphere hold carbon for geological timescales. When we burn fossil fuels, we short-circuit the slow geological loop and dump stored carbon back into the fast cycle. That's the enhanced greenhouse effect. The lithosphere holds 66 million gigatons. The atmosphere holds 830. The biosphere? Only 550. Watch the fluxes. Photosynthesis absorbs about 120 gigatons per year. Respiration releases about 120. Balanced. Stable. Then we added fossil fuel combustion, 10 gigatons per year. Natural sinks absorb only 2.5 extra. That leaves 7.5 gigatons accumulating annually in the atmosphere. The cycle is disrupted. The nitrogen cycle is trickier because bacteria must do the work. Atmospheric nitrogen is locked in an inert form most life can't use. Nitrogen-fixing bacteria, like rhizobium in root nodules, convert it to ammonia. Nitrifying bacteria then convert ammonia to nitrate, the form plants absorb. When organisms die, decomposers release ammonia back. Denitrifying bacteria in waterlogged soil convert nitrate back to nitrogen gas. Know which bacteria do what. Exam questions love this. Nitrogen fixers, nitrifiers, denitrifiers. Each one has a specific role. Humans disrupt both. For carbon, combustion, deforestation, and agriculture release CO2 faster than nature absorbs it. For nitrogen, the Haber-Bosch process doubled reactive nitrogen in the environment. Industrial agriculture dumps synthetic fertilizer at scale. Excess nitrates wash into waterways, causing eutrophication. Have one carbon example and one nitrogen example ready for essays. The IB asks you to evaluate human impacts. Watch this cascade. Excess nutrients enter. Algae explodes. When algae dies, decomposers consume dissolved oxygen, and oxygen crashes. Fish and aquatic life suffocate. This 6-mark essay favorite requires the full causal chain. Learn it. 3 terms. Transfer means movement without changing form. Heat leaving an organism, water flowing downstream. Transformation means changing form. Light becoming glucose, nitrogen becoming ammonia. Storage means sitting in a reservoir. Carbon in fossil fuels, carbon in wood. Use the correct word. Examiners notice. These aren't separate concepts. Photosynthesis is where energy enters. Food webs move energy up trophic levels. The 10% rule limits chain length. Climate change disrupts carbon. Eutrophication disrupts nitrogen. Biodiversity depends on available energy. Sustainability depends on cycling rates. Touch multiple boxes in your essays. Show you understand the big picture. You've learned how energy fuels ecosystems and how nutrients cycle endlessly. Next, biomes, succession, and field investigation methods. We'll explore Earth's major life zones, watch ecosystems rebuild, and learn how ecologists measure biodiversity and productivity. Stay tuned. 800 words, target 750, 850.